Hey guys, and welcome back. In this lecture, I'm going to show you how to web scrape images from Google to build your own image dataset. This dataset can then be annotated and used for training for your very own custom AI object detector using YOLO v3 architecture. For our object detector, we're going to be training it to differentiate between Xbox and PlayStation. And we'll train it not only for the game consoles, but also for controllers and branding. Our AI must also recognize which of these two are the better console. PC. Just kidding. We'll just look at these two classes for our YOLO 3 object detector. If you want to skip this video of image scraping and annotation, then you can go over to our GitHub repository and download the annotated dataset. Otherwise, let's continue. Download the repo. For web scraping, I'm going to show you two implementations. One is using a raw Python script, and the other is a pumped out Jupyter notebook where I basically package the current raw Python script and make it look really sleek with a graphical user interface. I'll show you how to use both of these methods. So all should work well if you have all the dependencies installed in your Conda environment and with a Jupyter notebook installed. We installed most of these dependencies in the first lecture if you recall. So let's start with the first method. If you haven't already cloned the repo, you may do so with git clone. So first of all, let's go into Anaconda prompt. Let's first change our Conda environment to YOLO v3. And let's change the directory to YOLO torch. Gonna cd, do that. If you're using a different drive, you can just change the drive with this command over here. You can go over here, click copy, and git clone right over here. Git clone and paste. Then go into the folder 1_web scraping, and let's check out image_download.py. So what this nice little script does is that it downloads all the images of Google that have the keywords over here. It will download the amount of images specified by the limit over here, and this is per keyword. Now one caveat is that the dependency Google images download sets a default limit of 100. So if you want to download more than 100 images per keyword, you will have to link to the Chrome driver executable like I have over here. So in our repo, I've included the Chrome driver over here, and I've placed mine in this directory over here. You can place it in any directory that you want as long as you reference it accordingly. For our keywords, we'll type in Xbox, Xbox One, PlayStation, and PS4. We'll choose about 100 images of each to make a total of 400 images for our training set. Okay, so to run the app, let's open up Anaconda prompt. Let's cd into this directory over here. And type in Now when you execute the command, you might be bombarded with an error that says you are missing Google Images download dependency. To remedy the situation, you can type in Google image download pub. Then go to this one over here and click on the newer version. Copy and paste this right over here. So I already have it installed. So let's try the command again. You can type in Python or Python 3 image download.py, and there we have it. As you can see, it's downloading all the images from the keywords for PlayStation and Xbox. We can go over to our folder, and in downloads you can see it's starting with Xbox. Let's just wait for it to download all the images. Now just remember that not all images in the dataset will be relevant. The images will need to be filtered. And filtering is a very tedious process, which can give you nightmares, especially if you have a dataset of over 1000 images. So that is why I recommend that you get yourself a student or pay a freelancer to do filtering and annotation for you. For this dataset, I'm going to do it myself as it's a very small dataset. So looking at the pictures, most of them look relevant. We can even combine our Xbox folders and our PlayStation folders together. Now I'm not sure how well this detector will work with a relatively small dataset. Normally you would need over 1000 images for the CNN to generalize well over various inputs. However, if you want to multiply your dataset with one click, I'll show you how to do this with data augmentation. Data augmentation basically duplicates your images and annotations. but you can flip, resize, crop, and rotate your images so that your neural network thinks that it's looking at different images. Meanwhile, they are just modified versions of the same image. However, just note that this is not a substitute or replacement for getting more data. It's just an aid for getting better results. Okay, so that is it for web scraping. In the next lecture, we're going to be going back to Supervisedly, where we'll upload and annotate our images. It is a painstaking process, but it has to be done, either by you or someone else. Oh, and before I forget, the second approach that uses Jupyter Notebook. It works essentially the same, except we have a really nice GUI. If you run all cells, you can see it hides all the code, and all we left with is our graphical user interface. So we can type in all the keywords, Xbox, separated by comma. You can type in Ninja, Panda, etc. You can change your limit. You can put it up to 1000, even more if you change the code. Finalize the settings. So it shows in your keywords, the limit that you set, and then we can click this button to execute. And then as you can see, it'll start downloading our images. Okay, so that is it from me. Thank you for watching, and we'll see you in the next lecture where we'll start annotating our dataset.